Hello, Honors Algebra 2. Today we'll be doing a starred section, another starred section, section 8-2, adding and subtracting rational expressions. And our objective, surprise, is going to be to add and subtract rational expressions. The best way to do these is kind of jump right into the examples, and we're going to get right into that. We're going to skip the first example in the book. So in the book, this is actually example 2. And here's what we want to do. We want to do 3y over 2x cubed plus 5z over 8xy squared, like that. So the way that you have to do these is just like adding any other sort of fraction together. They need common denominators. Okay, this is not the same as this. They do have a few things in common, but they're not exactly the same. So what we're going to need to do is find the things that are the same and multiply in the things that are not the same, okay? So, for example, in this first one, if I look at this 2x cubed and I say, okay, what's in the second denominator that I'm missing, okay? And so you always have to make things bigger. You can never really make things smaller. So I have an 8 here, a 2 here. If I wanted to, I could turn this 2 into an 8 by multiplying by 4. 2 times 4 will be this 8. I have a single x here. I have 3 x's here, x times x times x. So I don't need any more x's. But I have 2 y's here, and over here I have no y's at all. So I need to multiply by both of those y's. And I can't just do it on the bottom. I have to do it on the top also, because I need to multiply by 1 in some clever fashion for each one of these. Okay? So then the same thing over here. And 8 is the bigger number, and I'm able to make 8 here by doing 2 times 4, so I don't have to worry about the 8. 3 x's here, only a single x over here, so 3 x's here, a single x there. So I need to multiply by 2 more x's. That's what I'm missing there. I'm missing 2 x's, and that's generally what you're trying to do, is say, what am I missing, and multiply by that many things. Now, I've got 2 y's here, so I don't need any y's, because I'm going to wind up here, I'm multiplying by those 2 y's, so I'm just going to wind up with 2 y's there. So it turns out that all I have to multiply by are those 2 x's. Okay? So let's do all that multiplication. That'll be 12y to the third at the top, and 8x cubed y squared at the bottom, plus 5zx squared over 8x cubed y squared. So once I've done that multiplication, I can glance back at it and say, okay, yes, my 2 denominators are indeed the same, which means I can add the tops. And so I'll do 12y cubed plus, let's call it 5x squared z, so I'm doing things in alphabetical order. All of that over that common denominator of 8x cubed y squared. Now, if in theory you'd love to factor something out of the top to cancel it with the bottom or something like that, but if you've done everything to where you've minimized the amount of work that you have to do, that's not going to happen very often. Okay? So that's our first example. Our second example is example 3 out of the book, where we want to do 5 over 6x minus 18 minus x minus 1, all of that over 4x squared minus 14x plus 6. So there's a lot going on in this. One of the things I want to do before we start even looking at common denominators is I want to change this minus in the middle to plus negative, and that's going to have to be the negative of the entire top. I could interpret it that way, and let me call this plus negative 1 instead of minus here. And I'll keep the denominators the same for now. I still have stuff to do with those, but I want to talk about that later. So then I've got 5 over 6x minus 18 plus, and then I'll distribute that negative, giving me negative x plus positive 1 over this entire 4x squared minus 14x plus 6. Okay. Now I have to work on my denominators. And the first thing that I'm going to do with them is I'm going to factor them apart as much as possible. Notice that in this first one here, the 6x minus 18, I could actually factor a 6 all the way to the front of that and have 6 times the quantity x minus 3. That's going to help me later, because the more I can pull things apart, the more I can see what's missing. I might even want to think of that 6 as a 2 times 3 at some point. But, so then I've got this negative x plus 1 at the top, and on the bottom here, I can't factor out a 4 out of everything, but I can factor a 2 out of everything, leaving me with 2x squared minus 7x plus 3. And so then this 6, it will indeed help me to think of that as a 2 times 3. Now, so the idea here is I've got 5 over, let me write that as 2 times 3 times x minus 3 plus negative x plus 1. And the idea is that I would like to take, I'll keep the 2, and I would like to take this and factor it into 2 pieces, if that's possible. So the way I'm going to figure that out is the only way to multiply and make 2x squared is 2x times x times x. And if there's a plus here, then they both end in this, so it's, or they both have that operation, I should say. So it's 2x minus and x minus. And then what I need is I need the combination of multiplication here and multiplication here to add to make that. Okay? So if you think about it, then a 3 would have to go here and a 1 would have to go here, because those elements have to multiply to make that. And 2 times 3 is 6. 2x times negative 3, if you want to think of it that way, is negative 6x. And negative 1 times 6 is negative 1x. And negative 6x plus negative 1x is the negative 7x that we need. Okay? So this is, again, the slightly more advanced, but still from Algebra 1 factoring ideas. So now I need to separate these a little more, leave some room between them, so I can do the multiplication that I need. So I need to look here and say, what do I have there that isn't yet there, and vice versa. Okay? So notice I've got a 2 in both of them. This one has a 3. No 3 or any other numbers over here. They both have an x minus 3, so I don't need to worry about that. But over here, there's that additional 2x minus 1, and so I'm going to have to put that in because I don't have that yet. And so now I'm going to have the 2, the 3, the x minus 3, and the 2x minus 1, and I'll have everything. Okay? Same thing over here for the negative x plus 1 at the top. I have the 2, but I am missing the 3. That 3 right there has to be multiplied. Whoops. No, not yet. I won't do it in the same breath. Let me put all this here first. And then we'll do it separately. There we go. So, again, I'm missing a 3. So I'm going to multiply by 3. I've got the 2. So I've got 2 in common already. Missing the 3. They've both got x minus 3s. And I'm not missing any other stuff from there. So it actually turns out I can shorten this a little bit. And the 3 is the only thing missing. And so now if you look between what we're going to have on the bottom here and what we're going to have on the bottom there, we'll have 2, 2, 3, 3, x minus 3, x minus 3, and 2x minus 1 and 2x minus 1. So everything's going to have the same stuff, and that's, of course, what I really needed. And for purposes of saving a little bit of space here, I'm going to distribute and distribute so that on the top here I get 10x, let's call it plus negative 5, over 2 times 3, let me now put that together and call it 6 times x minus 3 times 2x minus 1 plus negative 3x plus 3 over 2 times 3 again, which I'll call 6, times x minus 3 times 2x minus 1. And you see that I've got the same thing in the denominator for both. So now I'll add the tops together. 10x and negative 3x makes 7x. Plus negative 5 plus 3 makes negative 2. Over 6 times x minus 3 times 2x minus 1. And then a quick check. I can't factor anything in the top. I can't factor anything to the front. Nothing's going to cancel. And there's no good reason for me to put the bottoms together yet, because if this is in the middle of a bigger problem, I might still be looking to cancel stuff, so this is a perfectly acceptable answer right there. One more example, and we will be through these. So let's move on to example 4. And in example 4, we're going to complicate things a little bit more, of course. And we're going to do 1 plus 1 over x over 1 minus x over y. And this is going to be like a culmination of a lot of the skills that we've dealt with here. Okay, so let's start by putting these together and getting single fractions on the top and bottom, and that way, once I've done that, it's easier for me to turn this division into multiplication by reciprocal. Okay, so the way I'm going to do that is, the easiest way is to take each of these ones and make them fractions with common denominators as the other part. So since that has a denominator of x, I'm going to call that 1x over x plus 1 over x, all of that over, and this bottom one right here I'll call y over y, since I have a denominator of y there, minus or plus negative x over y there. So I want to be very clear, this is that 1. This is that 1, okay? Which then allows me, now that I've got common denominators there and there, I can add the tops. So I've got x plus 1 all over x over, same thing here, I can add these numerators, these top numbers, y plus negative x all over that common denominator of y. And now that I've got a single fraction on the top, a single fraction on the bottom, I can do keep, change, flip, and have the top times the reciprocal of the bottom, so that'll look like x plus 1 over x times y over y plus negative x. I did keep, change, flip there. Multiplication by reciprocal is the definition of division, so I changed it to multiplication by reciprocal. And then I've got y times the quantity x plus 1, which I could distribute, but I'm not going to right now, times x, or over x times y plus negative x. And again, I could distribute things, but that's a perfectly acceptable form of the answer right there, and you don't know if you're going to want to keep things apart to be able to cancel things later. All right, so that is section 8.2. Thank you so much for listening.